One more, okay, guys? We're going to go a little bit quicker. This is a parallel circuit this time. We're going to approach it the exact same way as we approached the last one. This is from Unit 3, Handout 3, so it's the next handout. It's question number 2. Nice little parallel circuit there. First thing I got to calculate is XC, but I'm going to follow the same steps. So XC, guys, 1 over 2 pi FC, right? And so if I calculate that, it's 2 times pi times 50 times 0.00004 equals 1 over x equals. So 79, guys, 79.58 ohms. Okay, that's supposed to be an ohm symbol, okay? All right. So that's step 1. Now, what are we gonna do? Step 1 for any circuit that I notice that I have to calculate power is figure out the current in the circuit. This is a parallel circuit, so I cannot draw impedance phasors, but I can draw current phasors, and that's what I'm going to do. I'm going to calculate IXC. It is going to be 120 over 79. Okay, so 120 divided by 79.58 equals, looks like this one's 1.5, 1 amps. All right, I'm going to calculate XL. Going to be 120 over 60, so that's going to be 2 amps. I'm going to calculate R. No, these are I, right? IXL, IR. Okay, guys. 120 over 30. 120 over 30 is 4 amps. All right, guys. Now, next thing I'm going to do is draw a current phasor diagram. Okay, guys. So here's IR. Comparing all this to the voltage. All right, guys. IXL needs to be drawn so that it is lagging, so it's down. Right, guys? IXC, 1.51. Okay, this little bit there is IX. All right, and it's going to be, looks like 0.49. Okay, it's 2 minus 1.51, okay, so 0.49 amps. All this so I can accomplish step 1, which is calculate the current in the circuit, okay? I total. 4 squared plus 0.49 squared, okay, guys? So 4 squared plus 0.49 squared equals root equals 4.03, okay? 4.03 amps. Okay, so step 1 accomplished. Calculate the current. Step 2, calculate the power factor. Okay, so the power factor is equal to adjacent over hypotenuse. Okay, so it's going to be 4 over 4.03. 4 divided by 4.03. It's going to be high. 0.99. Okay, 0.99. Okay, guys. Now, step 3. All right, so look, step 1, calculate the current, did that. Step 2, calculate the power factor, did that. Step 3, draw power phasors. Okay, so I know my power phasor diagram is going to look like this. All right, it's going to look something like this. P is going to be here, VARS is going to be here, VA is going to be here. Step 4, calculate the VA. That's why I took the time to calculate the current, because the VA is going to be 120 times E total times I total, 4.03. Okay, guys? So 120 times 4.03 equals 483.6. Okay, 483.6 volt amps. Now I have to calculate these other two. Now, my power factor is 0.99. That's why I took the time to calculate it, okay? So this was step 1. This was step 2. You know, this diagram was step 3. There's 4. Step 5 is to calculate these two. Power is always the VA times the power factor, okay? So it's going to be this VA right there times 0.99. 478.8 watts. All right, guys? Last one. 483.6 squared minus 478.8 squared. All right, guys. So 483.6 squared minus 478.8 squared equals root equals 67.97 vars. Okay, guys, and I think we're done, because let's look it up here. Look, this is 0.99. True power, 478.8. Okay, VA, 483.6. Okay, VARs, 67.97. I total, 4.03. Okay, now if you look at the back of the book, I think the answers are slightly different, and that's just rounding. Okay, so I wouldn't get too excited about this number here. It's a little bit different, and that's because I did some rounding here with the power factor and stuff like that. It doesn't matter. All right, that's how you should do these. All right, now there's other ways we could have done it. Right, I could have calculated this current. I know this current and I know the voltage, so I could have calculated, VARS XC right here, multiply this times this, VARS XL, it would have been this times that, and then, power, true power, that times that, right? And then I'd have 3 power phasors, and I could have drawn them all and tried to figure it all out that way. And that's nothing wrong with that. Okay, that's a legitimate way to do it, if that's how you want to do it. But for me, this way works the best. All right, it's the Van Andel way. All right, calculate the current, calculate the power factor. Those are your 2 main goals. If you know the current and the power factor, you have enough information to start this phasor diagram. Okay, because the current times the voltage is going to be VA. Power factor goes there, and that allows you to calculate this and this. All right. Now your homework, and I know all this is terrible. Okay, Unit 3, handout 2. Okay, and Unit 3, handout 3. They are all questions getting you to calculate, power factor, power, VA, VARs, etc. And our next lesson, we're going to relearn power factor correction to unity and 0.9. Okay, guys? And you cannot do power factor correction unless you are super good at calculating, power, VA, VARs, etc. for any circuit at all. All right, guys? So give your homework a try. I'll probably take something up next week, and we'll move on from there. Okay, guys? So have a good one. Be safe.